All right, we are on lesson 14-1. Today's date is Monday, April 8th, 2019. We are back from our spring break, and we are talking about Unit 14 today. The unit guide has been updated. By the way, this entire unit fits in the span of 1 week, which means if I'm not looking at lunch, I'm looking at our guide. Here's our guide. We're done in a week. It's small. It's concise. The test is on Friday. There are no quizzes. Everything for homework is on paper. You will finish the homework in class every day. If you are not slacking off, you will finish the homework in class every day. My Algebra 1 class did this same unit, and they all finished every day. If you don't finish in class, it's because you're not doing the homework. It's easy. This whole unit I would consider a level 1 out of 5 easiness. It's super, super easy. That's a bad goal to make, but there it is. Because I had to speed up this unit. This unit is all on Khan Academy, but it would have taken us a month. I can get through it in a week. Let's not. Okay, so we're coming back here. Vocab. How many of you have seen something that looks of this form by quiet raised hands? How many people have seen something that looks like that? I see about 4 hands. That thing is called a polynomial because today we're talking about how to add and subtract said polynomials. So we have a ton of vocab. Today is our most vocab heavy day, but then after that we can just not have to worry about vocab. So what is a coefficient? It's a what that is being multiplied by a what? Quiet raised hand. I forgot to pass out the cards. Is there someone over here that wants to pass out the cards for me real quick? Thanks. Quiet raised hand, eventually with a card. What is a coefficient? It is a what? It is a number. Who said it back there? Chewy, it is a number. Here's my card, by the way. A number that is being multiplied by what? A variable. Was it you, Aurelia? It is a number that is being multiplied by a variable. So if I come back over here to Classroom Dojo, +1 for participating, coming back over here to geometry. Chewy, where are you, Chewy? Jesus. All right. It is a number that's being multiplied by a variable, which means this 3, that is a coefficient. This -2, notice how I'm saying -2, not just 2. -2, that is a coefficient. That 7 is a coefficient. This invisible 1 is a coefficient. Each of these things are not each of these 4 things are coefficients. This is not a coefficient. That is just a constant. So it has to be in front of a variable. Nod our heads. We're following. We're awake. All right. So a variable. What is a variable? It's something that we don't know yet. What is this something that I'm looking for? Take a guess. Go for it. Yeah, India. It is a number or a symbol. You can say either thing. I'm going to put number here because that's easier. But you could have said it's a symbol that we don't know yet also. It's a number that we don't know yet. This X could represent 5. It could be 3. We don't know. We know that that is called a variable. I'm not going to go through that too much in depth. Thank you, India. You can turn in your card too if you have it. What is a constant? Jaden, yes?
A number?
It is a number with no variable. Yes. Thank you, Jaden. Jaden is on it today. This 17 is a constant because there is no variable. No variable, therefore it is a constant term. Constant. This thing is a constant. We can label that. And these are all coefficients. All right. Finally getting to some things that you might not remember. A term. It's a number and or a variable separated by these 2 operations. What 2 operations are terms separated by? Think back to kindergarten. Easiest operations you know. Anna. Plus and minus. Thank you, Anna. So, oh look, I found a minus sign. Therefore, the thing that was separated, this 3x to the 4th power, that is a term. This whole thing, this whole unit is a term. This entire negative 2x to the power of 3. I know that it's technically separated by the negative, so I guess you could just be talking about this thing. That is also a term. There are a total of 5 terms here. 1, 2, 3, 4, 5 terms here. Each of these are terms. You can do a little square bracket. You don't have to label each of them. I think you'll know it by then. Each of those things are called terms. They're little segments, little units inside of the polynomial. All right. And then a polynomial, and I'm going to use a vocab word I've already defined over here on the left. A polynomial is a collection of one or more, Ellery? Careful. So these are just coefficients, but it's the coefficient with the variable, which is called terms. There it is. So thank you, Ellery. You are now in for the participation. So that is a weird definition because one or more terms. Do you want to see one or more terms that's a polynomial that you've seen before in the kindergarten? That is a polynomial. 2 is a polynomial. By the definition, it's a term because, I mean, it's separated by plus or minus. Here's plus 0, right? It's a term. And it's at least one or more term. It is one term. That is a polynomial by the definition of a polynomial. Kind of weird, but there it is. So, degree. This is something you might not have ever seen before. What is the degree? It's the what of all of the terms of a polynomial. Has anyone even heard of degree by quiet raise hand? You don't have to give the definition. I'm just wondering who has heard of this. No? Okay, this is the biggest exponent. It's the biggest exponent of all of the terms. I have to look at each and every single one of the terms. Which one has the biggest power? And what is that power? So I look back up here at my polynomial. I have a power of 4, power of 3, power of 2, power of an invisible 1. This is technically a power of 0. This is to the power of 0. Power of 0. Because really, x to the power of 0, anything to the power of 0 is 1. So 17, x to the power of 0 is just 17. So that's a degree 0 term. What is the highest exponent? Quiet raised hand, 4xp. Just tell me which one is the biggest. The biggest exponent is Colby. Therefore, this is a degree 4 polynomial. Thank you, Colby.
I think you spelled exponent.
I might have. Spelling is not my forte. I need Miss Taylor's help.
You added an extra T in there.
Exponent. Yeah, thank you.
It's not the last one.
Exponent. And where are, oh yeah, that's right, you're in here. Boom. I don't have a teacher error. I'm just going to do participating. Maybe just that and working hard, yeah?
That goes with it.
Click,
What are
click.
you doing?
Why is it not working? Working hard, yeah. Thank you. All right, exponent. Thanks for catching that typo. All right, so whenever you have a certain degree of a polynomial, then it has a special name. So this was a degree 4. Let's all label that here. Degree 4 polynomial. It's a degree 4 polynomial because 4 was the biggest exponent. So different degrees have different names. Yes, Jaden, question?
No.
Okay. So whenever I am a degree 0 term, that's something like 2 or 5 or pi. Whenever I have a degree 0 term, that's called a constant. Wait, Mr. Sindel, you already defined a constant. A constant up here is a number with no variable. Well, yeah, 2 is a number with no variable, so it's called a constant. 2 different ways of defining it. It's a degree 0 term. That's also a constant. A degree 1 term, that's something like 3x, because 3x is really 3x to the power of 1. A degree 1 term is called linear. You have studied these a ton in Algebra 1. Hopefully you studied how to solve 3x is equal to 9 in Algebra 1. If not, I have failed as a teacher. A degree 2 term, that's something like 5x to the power of 2, because 2 again is the highest power. A degree 2 term, which we are trying to get to, this is called a quadratic. Quadratic, which in my opinion is still weird. I don't know exactly why it's called quadratic. Whenever I think quad, I'm thinking of like 4-wheeled or 4 something quad, yet it's to the power of 2. You'd think maybe a degree 4 should be quadratic, but it's not, it's degree 2. Okay, degree 3, that's something like x to the power of 3. That's called a cubic. You will study them a lot next year in Algebra 2 if you decide to take Algebra 2. We study cubics. You also have degree 4 and degree 5. You can here make your own choice. You can call these degree 4, degree 4, degree 5. And if I have 6, it would be degree 6, degree 10, degree 10. So you don't have to remember custom names. The names that I will be testing you on this Friday is on constant, linear, quadratic, and cubic. If you get to degree 4 or 5, you can just say degree 4 to degree 5. If you want to know these because you're cool, like Mr. Sindel, these are called quartic and quintic. You do not need to write it down. Quintic, quartic and quintic. So you'll be cool. You'll be like, oh, that's a quintic binomial. All right. And finally, if you have a certain number of terms, that is also a special name. Lots of vocab. I warned you guys. Whenever you have 2 terms, I'm going to skip one for now. Whenever I have 2 terms, that's called a binomial. Whenever I think of bicycle, I'm thinking of 2 tires. If I'm thinking of binomial, I have 2 terms. Again, terms are these segments that I'm talking about. This had 5 terms, so this would be 5 terms. There's not really a name for it. If I have 3 terms, well, a bicycle is 2 tires. What's 3 tires? Tricycle. So what should it be?
Trinomial.
It is triceratops. Oh, trinomial. Trinomial. A bunch of you were already shouting that. Thank you. And you would think maybe a unicycle somehow turns into a uninomial, and I agree that kind of sounds correct, but it's not. It's actually monomial. It breaks that tradition of bicycles and tricycles. Yes, Ellery.
For the quadratic degree, is there a reason that it's 5x squared, or did you just put that?
I just randomly put a 5, randomly put a 3, randomly put a 2. But the main thing that I care about is this degree 2 because it has a power of 2. Yeah, good question. All right, so we need to use both of these facts, the degree on the left, this degree on the left, this number of terms on the right, and combine them into one word that describes the polynomial. We are learning how to describe the polynomial. Let's see this one. Example 1, we're putting these 2 words together, 3x squared minus 1. Well, I come back up here to my notes. What degree is this polynomial? I need a quiet raised hand. What degree is that polynomial? I see 1 hand. I see 2 hands. Raise your hand with your card if you still have your card. I'm going to give you a preference. Beverly, go for it. It's quadratic because degree 2. Exactly, yeah. So thank you, Beverly. You can turn in your card. It is quadratic. So let's go and write it down. Quadratic. Well, not really. You just have to name them. I'm testing you on how to name them. Quadratic. And I need the second name. Is it a monomial, binomial, trinomial? Are there 4 terms, 5 terms? Usually I'm going to keep it at 3 terms limit. It's a quadratic what? Quiet raised hand. Quadratic. India has her hand up. Anna has her hand up. You have your card too, India? Oh, okay. Go for it, India.
It's a quadratic binomial.
It is indeed a quadratic binomial. Man, doesn't that make us sound so smart? You can go home and be like, Guardian, I learned how to study quadratic binomials today. You're like, what? You're so smart. Yeah. Quadratic binomials. Thank you, India. All right, next, I have this beast. This quadratic? No, it's not quadratic. It's something else. This beast is known as, I need both words. If you have your quiet raised hand up, I see Eller's hand. I'm looking for more hands before I call on someone. What is this beast of a polynomial known as? It's not a triceratops. Martine, go for it.
Cubic trinomial?
It is a cubic trinomial. Thank you, Martine. Man, we sound so smart. Cubic trinomial. It is a cubic because it's a power of 3. Power of 3 means cubic. And trinomial because there are 3 segments. Trinomial. There are 3 terms. How many segments? 3, so trinomial. We're on the back. And finally, that's a polynomial. -10. I warned you it's a polynomial. What is it known as? I see 1 hand. I see 2 hands. I see 2.5. It was Cheyenne in her hair. 3 hands. Four hands. Ellery, go for it.
It's a constant monomial.
There it is. A constant monomial. Thank you, Ellery. Constant monomial. You will be responsible for remembering everything in this table from 0 degree to 3 degree. You don't have to remember 4 and 5. Just remember degree 4, degree 5. And monomial, binomial, trinomial. That stuff will be on the test. It will be on the homework. All right. By the way, since we have paper homework and you're bored on the notes because you're like waiting with your hand raised, you can start on the paper homework and finish it by the time we even finish this lesson. I'm okay with that. Combining like terms. This is our bread and butter today. If you know how to eat bread and butter, you know how to combine your like terms. That is the most important thing you'll be taking away. You'll notice there is a star coming up here. Like terms. What are like terms? They're terms that have the same what and the same what. They have to have these two things. That's all I care about. I see one hand. Who wants to take a shot at it? Leo looks very interested. He's like, I know it. I'm just not going to raise my hand. I'm too smart. Ellery, go for it.
They have the same degree and polynomial.
So you're really, really close. So you have the same degree. You're correct there. And the same...
Number of terms.
So let's, instead of degree, I'm going to use the word exponent because it's going to be easier for us to remember because degree is a harder word. But you're right. It is degree. So I'm going to say exponent. But to fix your definition, Ellery, can I add x and y? Why? The same letter, right? The same variable. Yeah, so we're going to use the word variable here. You're looking at the power, you're looking at the letter. If they have the same power and the same letter, you are ready to add them. They are like each other because they have the same power and the same letter, the same exponent and the same variable. That's why we call them like terms, because they are like each other. They're very similar. We are all like people because we are all humans. All right. And here's the key thing. We are only allowed to add and subtract. Use that word that we just defined. Someone, quiet raise hand. What did we just define? Quiet raise hand, quiet raise hand. What is that term that we just defined that I'm writing down? Anna?
Like terms.
There it is, like terms. Thank you, Anna. There you go. If they are like terms, if they have the same exponent and the same variable, then we can add them. So let's check out an example. 7x plus x plus 2. I need to find the like terms. Then I need to combine the like terms. Again, I'm looking for the same letter and the same power. Who can help me with example 4? Lorea, go for it. It is indeed 8x. And then I can't do anything with a 2, so there's my answer. There it is. Thank you, Lorea. 8x plus 2 is the answer. Whenever you're adding, you add the coefficients. You add the number out front. Leave the letter. The letter does not change. The power does not change. It was power of 1, power of 1, power of 1. I will say this again because it's super important. You'll get it mixed up when you start multiplying. Whenever I'm adding or subtracting, I never, ever, ever change the power. The power remains the same. On to example 5 and 6, which are very like tonight's homework.
Oh, you double-sided it?
The back has the answers. The front has the questions.
You should not have said that.
It's to check your work. If you just write down your answer and it looks like you're not doing the work, then I'm not going to give you the credit. I'm going to, on example 5, I'm going to first drop the parentheses because I have a plus sign. If I have a plus sign, you are allowed to drop the parentheses. Scribble them out. They're not there because there was a plus sign. If it is a plus sign, scribble them out. Hey, example 6 has a minus sign. You're not allowed to scribble them out yet. All right, now that I've dropped the parentheses, I'm going to add the like terms. What are the like terms and how do I add them? How do I combine them? Quiet raised hand, help me out. I want to give preference to people that have cards. I'll still call on you if you don't have a card, but I want to call on more people. People that have not participated yet today.
Man, could you stop listening?
Yes, I do appreciate you stop whistling.
Oh.
Sam, go for it.
-7 + 2.
Oh, you said that so correctly. -7. Not just the 7, but the negative as well. So the -7y and the 2y are like terms. They add to -5y. Sam has half the answer. Thank you, Sam. If you have your card, you can turn it in. And I have to do the other 2 like terms. Who can do that for us? Someone that still has their card. This is an easy one. Easy way to get XP. Easy way to level up. Easy way to get that power to redo quiz questions. No. Bev Cheetos, go for it. 6 minus 2. So I have this 6 and this minus 2, which forms a +4. There it is. There is our final answer. It is -5y + 4. If you're yawning because this is so easy, I'm doing a fist bump. That is awesome. Okay, example 6 is the hardest type of adding and subtracting problem that I can be giving us with one variable. It's because it's a minus sign. I'm not allowed to drop the parentheses until I distribute that negative. I will show you how to distribute right now. Here I go. This negative is going to go into each of these 2 terms. The way that I show that is I change all of them. This negative is now a plus. This plus is now a negative. This negative is now a plus. That is how I show my distribution of a negative. I'll do that once again. I had this problem. I'm going to distribute this negative. It's now going to be used up. It's now a negative and a positive. I change all 3 of them. That's the quickest way of showing that you distributed the negative. Hey, now that we have a plus in between, Jaden, we can do what, Jaden? Something with those parentheses.
So you don't need to do anything on the other side.
Don't need to do anything to the left-hand side, no. Yep, as Jaden said, drop them. Get rid of them. Thank you, Jaden. You got some XP.
So if it's a positive, does that turn into a negative?
Whenever you're distributing the negative, yes. So this was a positive, it's now a negative. And it was a negative, so now it's a positive. They switch sides.
So if it's a positive on the, like the other 2, it turns into a negative?
I don't exactly get. So are you talking about like if you had terms in here that were positive, like
Yeah.
a +3, then yeah, you could scribble out the negative and turn it, or scribble out the positive and turn it to a negative. All right. So now I need someone to combine like terms and be done with these notes. Who can do that? Combine like terms. Help me out. I see 1 person that's ready. 2 people that's ready. Leo, halfway ready. Larry, go for it.
You had -7y and -2y.
Okay, and that forms a -9y. Perfect, thank you, Larry. That's the first half. The first half. The second half. The other like terms. Where are they?
It's a little bit further than this.
Sam, go for it.
You just have 6 and 2.
6 and 2 is +8. There it is. Final answer, box it. That is as easy as it gets. That is our homework for tonight. You can begin on the homework right now. It is currently 9:24. We get out of here at 9:49. You have half an hour to do, how many problems? Is it 10, 12? You might already be done.
I used all the problems on the back and stuff.
That is not okay. I'm going to make you redo it then. Go ahead and write a brief summary, something that has the words like terms. That's the main thing I care about today.